Welcome back. Is anyone here who wasn't in the previous session? Oh, the things you've missed.
Getting my hair.
Thanks everyone else for coming back. So in the last session we were going through this scene by Studio Niskota, and we've just started to talk a little bit about how Forest Pack was used in this. We haven't got very far actually with that. We've mainly talked about some of the changes in Forest Pack 6 and how we've changed the user interface a little bit, for those that weren't here, so that now you can choose which rollouts you see in Forest Pack. So that's a nice change so that you can optimise that work. What I didn't get around to mentioning was there are a few other changes as well, just little things that help people day to day. So for example, I'll press the wrong button. I've done that for a few minutes. Yeah, so for example, lists are now resizable. This is a small thing, but it helps people a lot. You can change the size of any list now, because when you've got a lot of objects like this, you couldn't necessarily see everything very easily. So you can resize these now, no problems. And the other thing is you can see I'm hovering the mouse over it, displays the full name of whatever's under there. So it's a little thing, but again, it makes life a little bit easier. The other thing that we've changed is to, like I say, make things easier to hide, and we've also added a select all forest dependencies option. So that now means if you've got a forest object and you want to select all the areas and the geometry and the surfaces and everything else that apply to that one object, so you can export them, you just pick that option.
That's so good.
It's a little thing. So those are some of the changes we were just talking about. Okay, so you've created your object with the new streamlined interface, and the first thing you're going to do is start adding things to the items list. Nice and easy. So we're going to generate mode, we just pick our surface. This is the very slow creation of this Niskota thing. And we have our geometry list. So first things first, you probably know you can add multiple objects, but it's surprising how many people don't. You don't have to pick objects one at a time, you can pick multiples from the scene. And another thing I wanted to mention is that, check me out if you're using the list, is that it's very hard to see this distribution of objects. I can see a lot of objects up there, but I can't see how they're reflected in the scatter. So a handy tip for me is that I turn on Use Color ID in the display rollout, and in that way, it displays in the point cloud the colours that you can see, in the items list. So you can get a better sense of what you're actually scattering. So in this case, I'm going to lower the probability of everything to 0 and increase just the blue one at the top there to 1. Now I can see the makeup of this scatter based on these colour codes up here. So that's just a really handy way of being able to visualise your probabilities, as you can see.
Can you now change the color ID of more than one object at once?
Yeah, you absolutely, you can. Yeah, you just hold down Shift, select them all, and you can change all the colour IDs. I'll do that in a little bit. The other thing you can do is you don't have to change the scale. For example, if you want to make something bigger or smaller of your source objects, you can change the scale globally, or you can change them individually per object. This is quite handy too if you want to scale one tree up in one Forest Pack object but not in another. That means you don't have to go and change the original and mess everything up. And the other thing I wanted to mention is this, which is a very important little box, so much that I'm waving my imaginary hand around it. This material box here in the geometry rollout causes some people a bit of trouble. And what's basically happened is when you pick an object from the scene, it instances the material that was on that object into this box. That's what it's doing. And it overrides then whatever was actually applied to the material, to the source object, sorry. What some people try and do when they're changing an object, the material object, is they'll try and pick the material off the Forest Pack object itself. And it's massive multi-sub-object material, which has got sort of colour IDs and everything else in it. Don't ever change that material, ever. You shouldn't need to, because Forest Pack auto-generates it based on this. Now sometimes what causes the confusion is you'll swap the material that's on the source object, and then it won't be reflected in Forest Pack, and then you'll sort of throw your monitor against the wall or something. It's annoying you. So the reason is that once you've picked the object, the original material is still instanced into this slot. Right? If you replace the material on the source object, it won't re-instance your new material to here. It's still using the original material. And that's why it doesn't update. So you either, if you want to change the object on your object, you either instance it into here instead of putting it on the source object. That'll work. Or just clear it. If there's nothing displaying in this box, it's automatically using whatever you've applied to your source geometry. And then that solves that problem. There is a way, I believe, of changing a few settings in the ini file so that it does that automatically anyway.
How is it with the consolidate and reassign materials?
So consolidate materials will do what it's taken to build a big multi-sub-object material based on what you've got attached to it. If you turn that off, then it's just using the material ID. It basically works like RailClone. So it's using the material IDs of this sort of geometry. And reassigned material will rebuild the material.
Do you have to click reassign? So if you change out the material in the material slot, do you then have to click
No,
reassign?
basically, I mean, what it might do is pull it back from the object. I don't touch these two things, to be honest. If I want it to use what's on the source geometry, then I'll just clear it. If I want to assign something, if there's nothing on the source geometry, for example, and I want to put it in here, like our presets, for example, if you look at the source geometry for the preset, there's no materials on them because they're assigned through this slot instead. Yeah.
When you pick new objects, why does the default object stays on?
Yeah, it's annoying, isn't it?
Yeah.
Yeah.
A lot.
Yeah.
Some people tend to forget to delete them.
Yeah, yeah. Actually, you missed it, but I did the same thing.
I know.
You spotted it.
Yeah.
Yes. Okay. I'll feed that back. One thing I would say is one way I get around that now, because I use RailClone and Forest Pack. I've started to use Forest Pack where I use RailClone just to create an icon first, and then add geometry and everything afterwards. And when you create it that way, your geometry list is empty, and so that problem is gone. Okay. So another question we get asked actually quite a lot, like almost weekly on the forum, is how to use groups with the geometry list. And what if I want to apply a group of objects? How does that work? And you can do it, but there are some quirks that it's worth being aware of. So for example, we want to scatter the table and chairs in this open-air restaurant. If I just pick the geometry from the scene, by just clicking on, this is a group, by the way, that wasn't clear, already a group. So I just clicked on it, and obviously it picked the object that I clicked on. It didn't pick the group, and that's the first hurdle. So there are two ways you can handle that. You can either use the add multiple and pick the group from there, and that will add the whole group. Or what you can do instead is you can go into group and just open it, and then you can pick the kind of brackets around this group, and you can do it that way. So that's the way you can pick groups. I'm saying two ways. It's a simple thing. But there are some other quirks here. So first of all, groups, you'll find every object in a group is randomized individually. It's not randomized as one. Now that's really cool sometimes, like this. We want to create a really messy restaurant where all the guests are left up everywhere. But sometimes you want to randomize the whole group as though it's one thing. And to do that, you have to work a little bit harder. In fact, you have to do a little bit of a trick. So what we've got to do now is basically align all the pivots to a single place so they all share the same pivot. And in this case, I'm just centering them to the pivot point of the table. So every one of those items now has a pivot point on that table. Has that helped? Well, no. As you can see, everything's still randomized individually. So all I've done is change the pivots. I haven't changed anything else. And that's because no matter what I do, every object is going to be randomized individually. That's just the way this algorithm works. So what we can do is hack it a little bit instead. And what we can do is apply a noise map to the map slot in the rotation settings here. And then we can use that to drive the rotation of the objects. Now, because the pivots were in the same place, they're all sampling the same point on that noise map, right? That's what's happening. So because the pivots, it looks down under the pivot, what color's on the noise map, it uses that to drive the randomized rotation value. And then they all take the same value.
How can you make them to not go inside
Which one?
oh,
here?
Yes.
I just spaced them apart. No, there are collisions. So there's collision you can use in Forest Pack to stop things colliding. It's based on a sphere though, so it's not like based on the geometry because it needs to be able to process fast. So you could set collisions and stop that happening. I mean, really, these tables wouldn't be this close together, would they? Be a little bit claustrophobic. So there is a little catch here, which is that if I open the noise map, and I change the scale a little bit, now some things are starting to happen. Basically, you can see that now that's not working. And the reason for that is because I've foolishly left translation randomization on, which is taking that pivot point and then shifting it around a little bit, right? So suddenly those pivot points aren't lined up anymore. They're all slightly offset, which is why when I made the noise map so much smaller, suddenly they all went wrong. So the option is just to turn off the translation randomization, and then everything is sampling the same point on that noise map, everything gets exactly the same rotation. And there we go. Not the nicest looking restaurant, but you get the idea. Okay. So surfaces in Forest Pack, we need our trees to follow surfaces. So let's look at this area at the top here. We can put some trees on here. So the surface rollout, which is over here. Just going to change this to pyramid so you can see a little bit more clearly the direction of these things. And very slowly, going to go back to the surfaces rollout. Very slowly. Right. So what we've got here first of all is this direction setting. What this does is lets you keep either the objects completely vertical, or you can rotate them to follow the normal surfaces, the normals on the surface basically. Or you can go the other way and go down, or you can meet somewhere in between with the slider. We can also limit the altitude range, so we can cap the trees at a certain level, so they're not going above the tree line on a mountain, for example. And we can also cap them at the bottom as well, so we maybe don't want them in this river thing that's down here. Actually, in this example, because what the Niskota guys did was took a train and did that with it to make the mountains in the background. This doesn't work great down here, but you'll see later what it works. But so basically what you can do is you can cap the top and the bottom. And then you can also control the density based on a graph altitude as well. So what we've got here, there we go, look at that. Okay, so what we've got here essentially is on the x-axis. Where's my mouse pointer? Okay, so on the x-axis here, straight line, excellent. On the x-axis we've got the altitude, so the bottom of the altitude setting, which you've got on the left there, and the top is there, and up here we've got density. So what we can do from here is read this graph. So okay, at the bottom of the slope we've got full density, until about you're into the top third, then the density very quickly falls away to very little or nothing. And that's how you can control it with these curves. You can see it. It's a bit hard to see on this monitor, but you can see at the top here, it's starting to get less dense as I change this graph. So the other thing you can do is you can change the scale as well. So using the same sort of idea, you're on the x-axis, you've got the altitude, bottom on the left, top on the right. Now we can make this tree smaller. The higher up we go, maybe there's less oxygen, less nutrients up there. The trees get smaller. And we can control that completely during graph. You can also create some interesting effects with these graphs. So instead of being a linear kind of fall off, you can create kind of sawtooth shaped graphs so that you get interesting kind of banding up the mountain. You can do the same thing with slope range. So we've got trees growing on the cliffs at the moment. If we change the slope range to the angle, we can remove those from there very quickly and parametrically. And we can also change the minimum slope range too if we want. And you can control the density and the scale of these objects as well based on the slope angle. So we could maybe have some trees on those cliffs, but maybe again they're a lot smaller, they can't get a foothold, their roots can't dig in deep, they're teeny. And you can create any shape graphs that you want with these. There's lots of flexibility to do interesting things with those. So we talked a little bit earlier, I mentioned a little bit earlier, these kinds of train editing programs that we're starting to use to create some really nice landscapes. And And obviously one of the ways people use those in 3ds Max is to import a height map and use them to displace the surface. And if you've ever tried to use Forest Pack on a displaced surface, you'll know that it doesn't work, right? Has anyone tried it? So you can do it, actually. But Forest Pack doesn't scatter at render time, it scatters before render time. Displacement works at render time. So it's kind of impossible for Forest Pack to read that actual surface at render time and position the tree. So you have to use a little bit of a hack. And the way you can do this is with forest effects. And what's interesting about forest effects is it's a little bit like the macros we looked at before, which we looked at for RailClone. It's kind of like macros for Forest Pack. Who's used effects? Very few. Okay. Just give you a quick lowdown of what these things are. So we've got an effects rollout here. If you open up an effect, you can see it's a little snippet, an expression basically, which lets you control nearly any aspect of Forest Pack. There are many, many effects built in, which kind of amount to new features of Forest Pack. So if you haven't explored these, there's maybe a bunch of features of Forest Pack you're not seeing here. And you can see there's descriptions for them. You can also export effects as .eff files or import them. So if you've created a new effect for Forest Pack, you can share it with people, share online, share it with your colleagues, or whatever. Just put it on the forum. The way that effects work in Forest Pack, or some of the changes, so if you're not familiar with it, we won't appreciate changes, but now what we can do with effects is we can stack up multiple effects. This wasn't possible before, you just had one effect. But now you can have as many as you want. You can build them all up, one on top of the other. So for example, this one is just very simple, it's just randomizing from a sub-selection of objects, nothing fancy. Just create it here, and then you can import or export or load them from the library. So here, for example, I'm changing the objects by a distance from an edge. So what I'm doing now is I'm using a forest effect to create a different set of trees at the edges of the boundary. That's one effect. Then I'm adding another effect on top of that, which is parametrically animating the scale of them based on time. So that's just another effect I've stacked up there. And then, because we've got map support in Forest Pack 6, which is a new thing, we can add a gradient and offset that parametric scale based on a grayscale map. This is all something you couldn't achieve without effects. And then you get this kind of wave growing effect, but it's all done in Forest Pack. Nothing's been animated outside of Forest Pack. Everything's just done with effects, fully parametrically. I'm not saying you want to do this to this scene, but it's just an illustration of the fact that you can do it. And that animation is created just with that graph, so you can do what you want to. You get fully procedural animation, animating the scale, the position, and the rotation and everything. Just through graphs. Also, effects are updated for Update Manager, so as we discover new effects that we can use, we can just push them out to you. And what's interesting about that for us is, often these effects come from support cases. So people will write to us and say, how do you do something? We might go, interesting, we'll create an effect for that to make it easier for you. And then we can share it with everyone. So it's a nice sort of very direct interaction between what you guys need and what we can push out through Update Manager. But hopefully, I mean, what I haven't seen a lot of yet is people creating their own effects, which I also understand, because we've got time to dig into this stuff. But it'd be nice when people start to really get into this, because I think it changes Forest Pack and opens it up in really interesting new ways. So how does that work with displacement? Well, Forest Pack 6 added the ability to use maps in effect. So this is a basic example, right, to get the idea across. So here we have a basic noise map used as displacement. There we go, there it is. And you see Forest Pack's ignored it, because the surface was flat before render time. So what do? We go into a Forest Pack and we have a follow displaced surface effect. This is built into Forest Pack. We've got a map slot here. The map slots are new in Forest Pack 6, and we can just add the displacement map to that map slot. How does it know how far to displace it? What we do is we link it to the controller that's added to the surface. So we find the controller that is the displacement amount on the original surface. And the fact that they're wired together means if you change the displacement amount on the original surface, Forest Pack updates too. Now you can see it's jumped up in the air and it matches the displaced surface. But as you can see in the viewport, it's just happening, the displacement surface isn't there yet, it's just reading the map. Just reading the map and reading the amount and just pushing the trees up the relevant amount. What about if you want the trees to rotate to follow the surface? Well, that's harder, actually. Technically, that's there isn't a kind of rotation parameter that we can easily pull out of that. And what we can't do currently in Forest Pack is to read the adjacent pixels in the map to where it's, so we can't calculate the rotation based on that. But what we can do is a little bit of a hack, which works quite well, which is to convert your noise map into a normal map, just using a V-Ray bump to normal, so it's still parametric. And then we can pipe that into this other effect, which is called rotate to normal. So we just attach that to the map input. And then you just have to, okay, you have to just sort of tweak the angle a little bit to match the kind of map you displaced it. But that's all you have to do manually, is just kind of guesstimate that. Then you get a kind of simulation of what we had before in the surface rollout, being able to scatter on surfaces and match the normal direction of them, but now we're doing it on a displaced surface. This is only illustrating the viewport. It's not using that surface to actually do anything. And that's a pretty nifty effect. It'll also work if you're just using a smaller displaced effect rather than a whole terrain. You know, you've got like a mega scans displaced surface on something, and you're scattering smaller items. It will work on that too. It doesn't have to be this big thing. So if there's already curvature on this plane, it will sort of project it out along the normal of the existing curvature. So it should all work perfectly fine. But please test it and let us know. Because we had another workaround for this before, but since Forest Pack 6 has introduced map support, we can do it slightly differently, and this seems to be working okay for now. And it's just a case of adding that effect, instancing in the map, and connecting the displacement amounts together. Should work fine. So another question related to that, because it's related to effects, we had from ILM, is the ability to change the probability based on altitude. They wanted to be able to change the types of trees that were basically like an ecosystem. So they wanted to build an ecosystem that had a certain type of trees, like one level, middle, and so forth. So we can't do that with the existing tools, but we can do it with effects, and these are in Forest Pack 6. So what we did was we created a series of stackable effects you can build up that let you change which geometry is being used based on altitude. And then we went one little bit step beyond that and used a fall-off graph as well to be able to change that probability. So you'll find in there's a probability by altitude layers effect now that you can load in. It's got a probability curve and an altitude minimum and maximum. And then it chooses which items you pick from the items list to use. There's just a number, which sub-selection of items from this group you want to pick. And then there's a probability graph, so up here, full probability. This is the minimum altitude, maximum altitude. You can see that this particular, which is 1 I believe, gets less probable the higher it goes. So you've just got them in the dips. That's the idea. You can mess around with this and get really interesting probabilities and effects. You could sawtooth it if you wanted or something like that to create banding, and you can do all sorts. And the nice thing about this is because Forest Pack 6 allows you to stack effects, Forest Pack 5 did not, you can create multi-layered probability. So we have these which are these little light grey ones. You can't see them from the back, probably they've got 1 written on them. We've got the second one in the middle, and then we have a third set of geometry on top, just by adding layers. You could do that and have as many layers as you want, really. So again, changing the effects here a little bit. Just tweaking fall-off curves. So this time I've got higher probability at the top. So then at the bottom of the altitude range is a low probability, at the top of the altitude range, high probability, which means the tops of the hills are going to get this darker grey object. Like so. So I think this is taking it in a really interesting direction. For me, this is the start of being able to use Forest Pack to sort of in one object build the ecosystem. Okay. I would hope most people know what Forest Pack users know what distribution maps are. Yeah? Do you know how they work behind the scenes? So we're familiar with these little boxes. We see them in the distribution rollout, and they tell you the pattern that the Forest Pack is going to create your trees in, basically. But when it comes to creating your own and wanting to use them, it helps to understand exactly how they work. And that's what this little video is about. So imagine that this is a 2x2 bitmap. Imagine that I didn't just do that. So imagine this is a 2 pixel by 2 pixel bitmap. And it's white and black, black and white. That's your distribution map that you've loaded into Forest Pack into the bitmap. What's happening is it's creating one tree on the white pixels and nothing on the black pixels, and that's the essence of how distribution maps work, right? White pixels create a tree, black pixels no tree. And that's basically the gist of it. But also the resolution of that distribution map is also quite important, because this distribution map is 2 pixels by 2 pixels, which means it's capable of creating 4 trees before the pattern repeats. That seems obvious, but that's the way they work. So the built-in maps are 100 pixels by 100 pixels. So from that, you can know that they can create 10,000 trees. Is that right? Yeah. So if you created a distribution map that was twice that, then you know that that pattern would be able to create double that amount of trees before it started to repeat. Yeah. We've got some new distribution maps in there too, which are slightly larger, so they create more trees. But that's the general gist. The other thing is that there's this magical threshold setting here. So how does that work? Well, basically, yeah, I can't get to it. The threshold setting is basically at what point is a pixel considered to be white and does it create a tree? That's what the threshold setting does. So if it's 50%, then it's a mid-grey that's going to be considered to be generating a tree. If it's below that, you're not going to get a tree. And that's also why some people get a little bit, these are the new distribution maps. That's why people get a little bit confused sometimes when they use a gradient map and they get this. Now, why have I got a hard line? I've got a gradient map in there. What I'd really like is for this to fade out and then reaches the top. That's what people expect to happen. But that's not the way, as we've seen, the distribution maps works. Because the threshold is set to 50%, it's just stopping in the middle, as you can see. And if I change the threshold, I'll just move that line up and down. I won't get a gradiated effect. Other scattering plugins, I think Corona Scatter, for example, works using a probability system. So we did have some requests to use that system. We didn't want to replace the system we have because people are used to it and all their scenes will break. So what we can do instead is use Forest Effects, see a theme. And with the new map support in Forest Pack 2, we can add a gradient map and we can get probability mapping instead if that's what you want. So then in this case you just set your distribution map to solid and then you add a gradient or whatever kind of mapping you want. Maybe you're painting it manually into this density map slot using Forest Effect that comes with Forest Pack 6 and you get this type of distribution instead. And for some people, especially for painting, if you're using viewport canvas or something to paint your density, this is much easier to control than having to place individual points, objects, and spread them out a little bit. The other option we had before we had this, we had a substance that converted a gradient into a point map, and that was another solution. So you could use like a substance map to procedurally turn something you're painting into like spaced out points. So that worked kind of well too, but this is better because it doesn't need substance. Okay, so we're onto our scene and we've got our distribution down. Here we go, we just need to bring the bottom back down so that we're down towards the lake again. This is back to Niskota's scene, by the way. And then we can see our lake, so we can use the bottom limit there to make sure we don't get trees drowning in our lake. And then we can start to control this a little bit. So most of you are familiar with the distribution list, we've seen this. We can change the density here, but look what's happening. If I reduce the density down, this relates to some questions I was going to ask. The trees keep disappearing. You never seem to quite see how many trees you're creating, because at some point they thin out every single time. And that's because the limits that are set up in the display rollout, you can see there's a maximum limit of 5,000, I think that's the default. But as I was saying to someone earlier, if you reset these to 0, you remove your limits. And that won't happen anymore. So just resetting these parameters to 0, these limits to 0 in Forest Pack, means you have no limits. The danger though, is that you create accidentally billions of objects and bring your computer to its knees. So be careful you know what you're doing if you remove those limits. Personally, I do what I've done now, which is remove the limits in the display rollout, but keep this max density limit here. just so that I don't accidentally create too many trees. So you can also, as you can see here, you can also move the distribution map around in the scene using these offset and rotation controls. And you can change the distribution map to some of the new ones we've got here, which are slightly more patchy for creating objects which are layered up, which I think is a good way of creating nice natural variation. So we've got some new distribution maps which are better for layering objects one on top of another and getting interactions between them. Another trick that I quite like, stop that there. Another trick I quite like, and you'll have seen it if you've watched any of my recent tutorials I do this, is to use the clustering feature to add extra gaps to the distribution. So at the moment I can choose a map, sure, but what if I want controllable kind of holes, clearings in this forest? What I do, or started to do now, is to use the clusters feature, not for how it was intended, but to group together objects which are of the same colour ID. That's what clusters does. So at the moment you can see I've created clusters, and each cluster has the same colour ID. If I change the colour ID of all these objects to the same, I lose my clusters. But if I add a new disabled segment here, I create gaps. And those gaps are controlled now using this clusters parameter here, and they're a particular size. So I find that's quite a nice way of adding an extra level of randomization and knocking gaps into distributions in addition to the distribution map. And of course you've got all these other controls here to make these clusters a little bit more interesting, like you can change the roughness of the cluster shape, you can blur the edges so instead of having a hard edge they blend together, and you can add a bit of noise so you get gaps in the normal clusters and you get trees in the gappy clusters as well. That gives you a lot of extra control and things to play with. So that's what we're doing here, is just playing with those settings. That's too many trees. They are going to be starved of light. There we go, it's better. Okay. I just got excited about the cluster setting there. So finally at the end here, you want to add your splines to remove geometry. So I've got the whole surface covered, but obviously in the front here there's supposed to be a building, so we need to remove objects using exclude splines by picking these off. I'm very sorry to say that in recording this video I exposed a bug in Forest Pack 6 which I'm now showing to a whole audience. So can you please ignore that and I'll tell you what it is that happens. But you'll notice that as I'm picking these exclude areas, the plants underneath them aren't actually disappearing. And that's because the bug that I exposed means that when you rotate the distribution map, the exclude areas move too. It's been fixed, but I didn't have time to re-record it. So, another thing I wanted to mention about exclude areas, but open splines are really useful. Because if you use an open spline, you've got a thickness parameter, which removes trees from the wrong place. But you can basically clear a path through your grass or trees or whatever, just using single open splines, like that. Now is when I realised what went wrong, and just change the rotation of the distribution map. Oh, there we go, it's better. So now you can see that that's working as it should. There you can see that it closes it in now. So I find open splines are really, really useful for creating all kinds of different effects like that. Okay, we've seen randomized transforms. So there is a point to this, showing you this again. Bear with me. So here's our trees. We're going to randomize the transforms again. In fact, do you know what? I don't know about you, but I find myself doing this for nearly every Forest Pack object I create. Go to the transform rollout, turn on rotation, -10, maybe -5, whatever makes me happy. Turn on the scales to some pretty general settings. And maybe enable horizontal mirror. That's a nice one for creating some randomization. And I think, oh, we've got to do that again. But actually, this is what I wanted to point out. There is a way of making that your default settings. Basically what you do is you go to this very old preset button, which is in the general rollout. This is what we used before we had the library system to create presets. But if you name a preset here default and save it, your Forest Pack object will use those settings every time you create a new one. So how that will set up, all your transforms will be set up the way you want, and so on and so forth. In fact, you can of course save multiple ones in here too, but that's the one that will be used by default. So what you should see if I create a new Forest Pack object is that it has those settings set up automatically. What I would say about that is that when you do this, you should do this in a blank Forest Pack object, so that there's no geometry in there or anything else either, because otherwise that will be added as the default as well. So you want to keep everything else blank except the things that you want to change. You should see that my transforms are now set up using those defaults. And they will be until I change that default or delete it, and then it'll go back to the hardwired one. That's quite a handy, I find it a handy time saver. It stops me doing the same thing over and over again. Yeah, okay. I had a funny moment when I recorded this video. I added a lot of ducks for some reason. So here are our ducks. What we want are some grown-up ducks and some baby ducks. We all know that baby ducks look identical to grown-up ducks, but they're just smaller. So there we go. We're going to randomize. So what I've done so far is I've just randomized the scale between 20 and 120% on those ducks, which is great, because I've got some baby ducks, but also I've got some teenage ducks. And I don't really want those. So I need to get rid of the teenage ducks. And one of the ways you can do this is to use probability curves. So this is one of the more advanced scaling techniques. You've got a little probability curve button here, and it opens this fall-off edit. What you've got, along the bottom, you've got the range from the minimum scale, in this case, to the maximum scale at the other end. And on this axis, you've got the probability of something from that range being selected. So if I only want small ducks and big ducks, I need a spike on the left and a spike on the right. Trust me. So we can just go in and we can add this, and we can just drag that down. And then I should get, in theory, only big ducks and only little ducks. Now they're really little ducks now. Let's make them bigger. They're too small, they can't fend for themselves. There we go. Now if I want fewer little ducks, I take the probability down, more big ducks. If I want more adult ducks, fewer baby ducks, I take the other end of the graph down. And it's working like that basically, so you've got the scale along the bottom and probability on the left and right. You can also, of course, control the scale using maps. I think probably most people are aware of that. So if I drop a gradient in there, then I get a graduated age range of ducks from front to back. And you can control this with the fall-off, of course. So this is just a grayscale, pretty straightforward. You can also use XYZ, you can use like the RGB values to control specifically the XYZ scale and rotation if you want to as well, for creating really complex maps. You can also use this as a probability map, which is a little bit harder to explain, but basically what's happening here is that where it's black, it's basically the probability range that gets expanded each time. So where it's black, the probability range is basically 0, and the further you get down, the more of that range that you start to sample, basically. So by this end, you've got the biggest range of big to small. In the middle, you've got some mid-range of big to small. By this side, you've got no range at all, so they're all one size. And that's how the probability works. Okay. So we've dealt with our trees, and we've in a very roundabout way taken a few diversions. We want to look at the grass that's in this scene. One of the things about grass is that grass is very small, and areas of grass are usually very, very big. And you need to be able to cover grass in a way that's optimized. So Niskota's scene had these plants in them. So the ground cover is on the top left, the main grass thing. You can see these are either individual blades or individual plants or very small clumps of plants. When I scattered using those plants, I had 6.5 million objects for one patch of grass, which you can see there. Now, though Forest Pack can handle it, that is not the best optimization for that scene. 6.5 million objects is slow to render, even with Forest Pack. So what we need to do is to find ways of making that much more optimized. And the best way to do that is to create patches. I think most people probably know this. But just in case, these are patches. Your patch size will vary depending on your scene. I think this was about a meter across, this one. And basically it's pretty simple. You just create yourself a separate forest object and you add all your plants to it. So you can use the pick multiple button, don't pick them individually. Watch to see if I delete the default segment. Yes. And then we need to change the distribution. Eventually. So I set this to full just to get the most plants possible in there, but you don't have to, it depends what effect you're going for. And then of course you want to set your transforms if you need to, so put some randomization in there too. And the only thing I do probably that's slightly different from there's an old tutorial on our website for this you might have watched, but the only thing I do slightly differently from that tutorial is I fade out the edges a little bit of these, so I'll go into areas and I'll turn on fall off, down here density fall off, and I'll just change the include area and change the graph like that, so that there's a slight fade out of the grass towards the edges of the patches. And the reason being is when we scatter these patches, we want them to overlap. And if you don't do that, you'll get kind of double density where they overlap. So that's an attempt to remove that effect in case that's visible, really. Yeah, please.
You talked about actually earlier the problem when you're using patches over time.
Yeah.
Is there anything to get around that? It's kind of a, I know that it is a large problem when something is a significant slope, especially when it's the type of slope where the patch would be like elevated off.
Yeah, it's a difficult one. That I haven't really found an ideal solution for that. I did wonder about trying to use, and I haven't experimented with it enough to know if it works, but trying to use slope-based limiting to put small bits of grass where they need to go and large patches where they need to go to kind of compromise.
That's a good idea.
Something like that possibly could work. Most people know about edge mode, I imagine. Yeah, I'll probably skip this one. One thing I will just mention, you might not be familiar, I mean, just the, yeah, you know this, yeah, you've seen it in action. Come on, skip. One thing I did want to talk about is just quickly is how edge mode actually works, because some people think it's just cut, slice through, which is well, the sort of effect you get if you've seen GeoPattern, this new F-Storm thing, maybe not. It's which is like a displacement effect kind of, but with edge mode, what you're going to get is individual blades that overhang the edge will actually still overhang the edge, because what it does is it looks for the bottommost vertex on any element in that patch, and then if that's inside the area, it keeps the object. So it's not going to cut. It's not going to cut that bit of grass, for example. So you still get overhanging plants, as you would expect to in real life.
Is there a way to set where that height is measured? Because I noticed there's some grass clumps, there'll be like this bottom.
Yeah, no, it's not, but that's an interesting suggestion. So I will. Okay, optimizing. So we've got our patches now. And we can apply them to the whole area, which is huge. Turn it off. So another thing I've seen is, I mean, hopefully that's pretty obvious. But one thing I've seen is people applying a surface area and then leaving it on, but applying another spline area on top to remove things from the surface area, then adding more splines on top of that to add them back again. Which works, but it's a slow way of doing it, so just turn the surface area off. It's easier. So we can add a tree pack. So obviously, grass pack. We don't need grass way back into those hills. We'll never see it that far back. So you can just limit it to where you need to be. Okay. So first of all, we want to add our splines at various points. I've got a thickness spline here, so I'm removing grass from the boardwalks, I think. And then we need to limit the altitude range, so we don't want grass in the lake, obviously. So we can limit the altitude range. All the same things we've been looking at. And then we can see how many trees we've got. So this pop-up you can keep floating too, if you want to, so you can see how optimized your scene is. At the moment I've got 8,579 patches in this scene. We can do better than that. So let's pick the patch first of all. You don't need to do anything to that, you just need to pick it. It's just fine as it is. You can leave it as a Forest Pack object. It's appropriate. Okay. So let's change our distribution modes first of all. So now we've got a lot more viewport items, a lot more render items, 5972. When distributing patches, generally I use a solid distribution map because it's the most efficient way of creating the most geometry. The only thing about using black and white maps is where there's a black pixel, Forest Pack's still thinking about it. Right? So there's still a calculation point there. So if you use a fully solid white map, you've got the least thinking about it that there is. The trouble is it creates a kind of grid-like pattern, which you're seeing there, obviously because it is literally creating a grid of white polygons. So the trick to breaking that up is to use translation randomization. So in the transform rollout, just make sure you whack on some translation randomization. Hopefully I do that. Yeah, good. And that will just break the grid a little bit by shuffling stuff around. And then that's the most optimized way of creating the largest amount of stuff without seeing the repetition. You don't want to generally rotate patches on the X and Y, because you'll see the edges, and you definitely want the direction set to normal. If they're up, when it starts going up slopes, your patches will still be flat and you'll see the edges. Scale to fit sloped areas tries to remediate a little bit what you were talking about. If it's on slopes, it will scale. But often it scales in the wrong direction, so it makes it worse. So I generally leave it off. Okay, so we've got down from sort of quite a few thousand now down to 35. We're getting down there. So the other thing, obviously, that Forest Pack does is camera culling. So by going to the display camera rollout, picking camera, hitting limits of visibility, you can remove any grass that isn't currently visible. So that's hugely cut this down from like 80,000 to 10,000.
But when you do this in the reflection, you cannot see it.
Yeah, that's true. But what you've also got there is offset. Yeah, so you can just pull it back a little bit behind the camera as far as you need to. It'll still generally be more efficient than rendering sort of several hundred meters behind you, even if you pull it back a little way. The other thing that I often do is to turn on density fall off. So I can fade the grass out a little bit the further it is from the camera, because more often than not, when it's a long way away, you can't see that thing. And you can really reduce it by doing that. And you've got basically a minimum and maximum, and you've got a curve that you just saw there, which just diminishes the density based on that distance. We can knock another couple of thousand off of that just by turning that up. And you've got a much more optimized forest. If you think I've gone from 6.5 million or something leaved grass things in the original scene to 8,412. That's a massive reduction in objects having to be scattered. And it'll more or less look the same, really. More or less. Of course, I've done one patch there. You could do multiple patches to add more variety. But the principle would remain. It would still be 8,412 patches. The other thing we haven't really talked about too much is Forest LOD. I don't know how many people use or are aware of Forest LOD, but basically it lets you switch geometry and materials based on their distance from the camera, as LOD systems generally do. So here we have the trees with an LOD system, and head of it. Just going to jump ahead. Here's our Forest LOD. So what I've got is the same tree actually added 3 times, but I'm changing the materials. I haven't found a lot of benefit in V-Ray of changing the geometry, but if you reduce the complexity of the materials the further from the camera, then you can see some significant improvements in renders. So what I've got is sort of, like the one closest to the camera's got the full transparency and translucency and opacity and everything else, and then you remove the bump mapping the further you are, and then eventually you can remove the opacity and the translucency as well. So. And you end up with sort of, for example, in this example, 3 different tiers. Just to illustrate this, I've just changed the diffuse colour. It's not showing because it's got maps, but to green, amber and red, so you can see how the LODs are functioning, but it won't render that way. And then we'll just knock those trees out and just add this forest LOD just so we can see it. So this is the same tree, different materials. And there you can see now, using this system, that I've got the green area with the highest quality materials in the foreground, the amber area in the midground, and the red area in the background. This is controlled by turning on this little LOD, level of detail button here, and using the Forest LOD object. The max distance range is calculated from here, so you can override it. And the actual position at which they swap is controlled from the Forest LOD object itself, so you can control them actually per plot. You don't have to do it for the whole thing. So this is here, the max distance. If I change this, you can see I'm changing the point at which the green turns to the amber. If you don't want a hard line, because that might be very visible, you can also change this, the softness of that transition, a fade if you will, using the variation slider, which is just down here. So that will make that much harder to see, especially if the camera's moving. You won't see the popping so much.
You mentioned the optimizing the material, and removing displacement is like an obvious one.
Yeah.
But then that still requires going into the different materials yourself.
Yeah, it does. It's not automatic, I'm afraid.
But it would be very nice then.
That would be nice. but it's very dependent on how people set their materials up, isn't it? It is. The only thing I would say about displacement actually is that instance geometry in Forest Pack, displacement is ignored anyway, as far as I know. So I'm not sure you'll get any effect of applying displacement to an object you scatter with Forest Pack.
Bump map and normal map.
Normal map will work fine.
Okay.
Okay, so that's great if you've got a normal camera scene, but what about a virtual reality scene where the camera's looking every which way at once? How do you optimise that? Well, you can sort of still use Forest LOD in that. Ooh, that's exciting. Just fix that. So here's just typical, camera fly through. Everything's being culled within the camera's cone of visibility. That works fine, like I say, except for reflections. But what about this camera here, which is a VR setup? In this camera, you can see everywhere at once. But if I switch to it, if I've got camera culling on, then I only see one way. So that's not going to render correctly, obviously. Can you still optimize it? Well, you can, not as much, but you can to a certain extent. You can certainly use Forest LOD, because we can there's a Forest LOD in here already. I'm just turning the probability down, so we just have that on plant. So this is a Forest LOD now. This red one, it uses the same sort of color coding as we just saw. That's fine, we've still got the camera culling. I need to change my output size to a VR compatible output size. That won't actually help, but there you go. And then we want to come into the camera rollout and change this. So I've still got the camera assigned, but I'll turn off limits of visibility. So it's all around the camera now, but the camera is still assigned, and that's important. Now I can come into my level of detail, and it still works, but now, because I've got the limited visibility applied, it works radially from that point outwards. So, okay, I've switched the colours around just to confuse things. But now you've got better quality plants in the middle, and then the worst quality plants on the outside. But like I say, because it's still working, you still get your LOD levels. The other thing you can do is you can control the fall off as well. So do you really need that many trees that far from the camera? Is it visible? Can you control it? So yeah, I think you can, in a lot of cases, just by turning on your distance and scale if you want fall off. So I can turn on my density fall off and knock that down a little bit. What I'm doing in this video at the moment. There we go, I'm showing you the viewport items. So 24,187 viewport items at the moment. So let's turn on level of detail. First of all, we've got that, and then go to density, and we've got our edit curve up there. So you can see that it's diminishing the further it goes from the camera. On the scale side, it's a bit of a cheat, but sometimes you can fill in the thinning out by making the trees slightly bigger. Depends if you can spot it or not, but it's sometimes a little bit of a hack that you can do. So now I've got 95,000. If I turn them off, 290,000. So it's like a third of what it was before, a third of the trees that you had before. So that's going to be a big saving for those big renders. I'm just going to skip this video, but basically my recommendation for you guys to create good natural ground cover is to stack up as layers, because you can control them independently and you can get them overlapping in really interesting ways. It's a bit like I was saying about RailClone. Don't try and do everything in one Forest Pack object. Create a few, multiple Forest Pack objects. Stack them up in various ways, either using the different map types, distribution map types, or using different spline areas like Studio Niskota did, you can create really nice interactions. And they stacked up a whole bunch in this scene. So they had their long grass, they had rocks, they had dead leaves, lily pads in the foreground, sticks and branches, they had reeds, more reeds, grass tufts, loads of those. Actually, those are displaying, that's the 6.5 million grass tufts. Forest Pack has reduced that right down for the viewport display. That should be full now. There are a lot of mushrooms in this scene. I don't know if they've got a problem with damp or something, but yeah, there's a lot of mushrooms in this scene. More grass tufts, and then finally the trees. And those are all your kind of basic layers, but it's just this big stacking up of layers upon layers upon layers. In fact, the splines from above look like this. So you can, it looks complicated, but really it's just a lot of include-exclude layers just building up on top of one another to create this really interesting kind of diversity in there. And I'm going to skip that actually. We can come back to these this time. So scattering around things. What time did this finish?
Well, maybe around 40 minutes or something. Let me check.
Scattering around perimeter objects. You love PowerPoint? So we want to scatter some things either side of this boardwalk, and there's already a spline set up for it, obviously, because it's a RailClone object.
So if, just to interrupt you, if you want to have the QA session at the end of the talk for about 15 to 10 minutes, then talk around 40 minutes.
Thank you. So we have a RailClone object set up with splines already there. If I apply this spline into the include area, remember you've got this open spline, so you can use thickness control just to push the objects out either side of it, which is brilliant, except that they're growing also through the boardwalk. So the trick is here, is to apply the spline twice. So I'm just showing it on the boardwalk. So you apply the spline a second time, make it an exclude area, and make it a smaller thickness than the first spline. That seems logical. Then you get them just on the outside, like this.
How come it only works for this?
I'll come to that. And then the other thing you can do is you can use your density fall off, of course, and you can just graduate that down so that instead of it being a hard finish, you can have fewer plants the further they are from the boardwalk, if that's what you want. So you can use those features all together. The nice thing about this is that the Forest Pack and the RailClone object are all controlled by the one spline, so it's completely parametric. Everything up there. So it's interesting, the question there was, why does that only work with closed splines? And that's the question I asked as well, so now it doesn't. So this is a Forest Pack 6, one of those other minor changes, but I think quite helpful. If I quickly grab two types of grass, like a healthy grass here, for example, and I want to fill in these areas with healthy grass, and then I've got like a desire line, like a footpath going through the middle where I want the grass to be slightly more dead, then I can use this new technique to kind of create that effect. So here I apply my healthy grass, like so. I've got a little patch of that. I'll switch to a camera view and just put a render of that, and it looks kind of like that, which is okay, but this is a very unnatural edge. Like, this should be dying as it gets to here. So what I can do is take this object and just duplicate it, because we've already got the areas and everything selected. So I'll just clone it, give it a name, unhealthy lawn, that says, keep it at the back. And then I think I pop open the RailClone Explorer. Yeah, okay, now I'm picking an unhealthy grass layer. These are in Forest Pack 6, these defaults, by the way. So I'm picking an unhealthy grass layer, one that's got a little more brown stuff in it there, and then that will do to fill in this part. So then I've got two objects, this one which is my healthy lawn inside the area, and the unhealthy lawn which is also currently inside the area. Both there. Okay, so this is a roundabout way of saying, look, there's a new button. Force open splines, which basically does exactly what you said. If you click that, then instead of filling in the area, it uses a thickness to draw either side of the area, even if it's a closed spline. that. And then the nice thing is that I can also apply that spline again as an exclude area, the way I did before, and maybe cut the center out of it. So like that. So now I've only got it outside this spline area, and I've got inside the spline, I've still got the healthy lawn. So you get this kind of fade towards the edge. Well, actually, what you've got is completely different geometry. You've got dead lawn here, sparse dying lawn here, and healthy lawn inside. And then, okay, this is a quick test, just grabbing some presets, but you can imagine with a bit of refinement, you can get some nice effects. Another way of doing this is using fall off in a fairly advanced way. So, you can add little using fall off curves, little being just stuff, something around. So here are our objects. I'm just going to whip through this, this is a fast one. But basically what we're doing here is we're adding the surface, and then to this surface, you're going to add fall off. Include fall off of 2 meters, exclude fall off of 2 meters. So the magic button here that I'm pressing repeatedly is this one here, invert curve. So basically what fall off normally does on an include area, it will gradually remove plants from the edge. Yeah, usually fade away. If you hit invert curve, it flips that around and you get nothing in the middle, and then you get plants gradually building up as it goes towards the edges, based on the measurements, 2 meters in this case. So what that'll do is it will put plants like you're seeing in the background here, just on the border of this include object. Now what's interesting about that is, when you start playing around with that possibility, mixed with the ability to use include objects and exclude objects, plus the fall off curves, plus this ability to invert curves, you get this interesting ability to scatter all kinds of things around the perimeter of objects, under trees, around paths, and that kind of thing. So this is a kind of accelerated version of that. So here's our fall off curve here. You can see we're just creating just objects around the edge of this surface. Another interesting thing is, if I take this point here and just reduce it just slightly, it fills in a very sort of small scattering everywhere. Because I've brought the fall off down below 100%. I can scatter inside curves and outside curves by just changing the include and the exclude areas. I can scatter on objects. This is just a geometry object. Picking that and just changing the invert curve, so it scatters around that now. This is a RailClone object, so in this case, I can just pick up the spline and move it around and everything updates. Also here, we can add this path spline to an open spline, and you can do the same thing here. So you can increase the thickness here, and if I invert the curve, I'll get it thicker towards the outside of the path, which is where you probably expect the stuff to capper, on the outside of the path. If you pick another Forest Pack object, then you can scatter around the base of that Forest Pack object. So you could put leaves under trees, for example. Again, it's a fall-off curve, an inverted fall-off curve, so it's building towards the point at which the tree is. And it's nice because it's interactive and parametric. If I change the distribution of the trees, all the grass changes underneath the trees as well. If you use paint areas, you can paint exactly where you want your litter fall to be, either include or exclude. So you want it to fade away from that edge or fade into that edge. It just depends what you need. There's loads of possibilities for those fall-off curves, and they're worth spending some time experimenting with. We're going to skip that. I think most people familiar with paint areas? Would you say? Yeah. This is a new thing. Okay, scattering on splines. So this is the Forest Pack 6 thing. We've got a new spline mode. So we have this boardwalk which has got splines on it now for the things. We have the existing distribution mode which you're all used to and have seen. But what's new is this drop-down list, which gives you the other distribution modes that you now have, one of which being is path. So if you pick the path mode, what you can do is distribute parametrically along paths. I know there was a kind of version in the tree editor mode, but this is different. So now we have the ability to adjust the spacing interactively. You can change the offset of the splines, and you can also put them in vertex positions if that's what you want. But the difference here is this is all parametric. If I change that spline, Forest Pack update, you don't need to rebuild it. You can also build them in a sequence instead of randomly, so we'll just sequence through the items list. A little bit of RailClone in Forest Pack, basically. And do loads of other cool stuff like that. You can still use all the randomization features and so on and so forth. So I know what probably most people are saying or thinking, which is that's great, you can scatter light geometry, but can you scatter lights with RailClone or Forest Pack? I'm afraid the answer is no, you can't. We're getting your hopes up. But you can kind of hack it a little bit to find a way to distribute lights with Forest Pack and RailClone, and this is currently the non-scripted way of doing this. So someone can tell me why Premiere, that's fine today. So basically what you do is you use Forest tools to convert your Forest Pack object to native instances in that scene, converts them to objects basically. So I'm just saving them to a layer that I can identify, not freezing them, and I'm going to not disable the object at the end, so I keep my original Forest Pack object, and then just instantiate it to create geometry. So what I have in the scene now is one object where each light was as well. And from there, it's a pretty simple case of going in using Max's native tools to put a light there. So I can just create myself a light. I'm going to instance it, so it doesn't matter at the moment. You can change it to whatever you want later. So I can just create a light in the scene. I'll go to Max's native, align, clone and align tool, and then just pick a list, pick all those objects which I saved in a layer that I remember the name of, hopefully. So I can just pick all of those. Like so. And then you can make sure it's instances, so it's easy to change them. If you want to offset the alignment or the rotation, you can do that here too. And then eventually you can just hit apply. You can see you've got lights now on all the lights. Now of course the catch here is if you change the Forest Pack object, you have to do that again. But it is a way of distributing lights with Forest Pack that can still be quite handy time saver. The other option of course is to use MaxScript. So someone asked me earlier, I can't remember who, about MaxScript being a way of using MaxScript with Forest Pack. Now Forest Pack is almost entirely scriptable. From the interface down to the tree editor mode is almost entirely scriptable. You can see if you've got the listener open that nearly everything comes up with a MaxScript equivalent. Tree editor mode is a little bit different. That doesn't show up, but you can find that by looking at our documentation, or you can do the show interfaces thing if you're a MaxScripter and find all that stuff. So using MaxScript, we've built a few scripts that are available on our forum. You can download these for free, that do stuff like instancing lights that you might find helpful. So this, for example, is a simple script that takes a scene which has instance geometry in it already and turns it into a Forest Pack object. So if you had like a scene someone sent you, had loads of instanced objects you wanted to convert to Forest Pack, then all you need to do is make sure you've got a new Forest Pack object, it's in custom edit mode, and it contains one of the objects which you want to instance, and you can hit that button there, and it converts those instances into a Forest Pack object for you. So it's really handy little conversion tool. I've heard of people going between Maya and 3ds Max and stuff like that using this technique. The other option is more or less what we were talking about, the lights, where you can do it the other way around, and if you've got a Forest Pack object and you want to put an object at each Forest Pack instance and match the scale, rotation and everything else, then you can use this script available on our forum, and all you do is you pick the object you want to distribute. So for a light, for example, hit instances to Forest, and it does that for you. And that's pretty much all it does, but it's a nice quick way of very easily distributing lights on Forest Pack objects. And they're just some things we've made based on support requests for the most part, but if you're a MaxScripter, you can certainly do a lot with this and help and work it into your pipelines and create your own sort of time-saving tools. I've got a little bit of time left, so I'm going to skip ahead a little bit, because I think we have... I'll just go through this one, because this was a question. So, tree editor mode, most people are familiar with as a way of switching your parametrically scattered objects into something where you can edit each tree individually, right? And you can refine your composition, you can move each tree and scale it and rotate it and tweak it just so. In that mode, there used to be a thing called reference object mode, which would allow you to place trees on any other objects in the scene. Like basically, if an architect had sent you a a plan where you put markers for trees and you wanted them in this particular place, you could use Forest Pack to pick those markers and plonk your trees down in those places. That was reference object mode, and this has been replaced now with a new distribution mode instead, which is here. So here in this scene we have a surface here, and we've also got a number of individual markers. So you can see if I add those, it puts a tree on each marker. That's fairly straightforward. If I use face centers, it puts a tree on each face on each polygon instead of each pivot point. So that can be useful too. You can also match the scale and alignment of the objects, but crucially, these are linked. So if I move the marker, then the tree moves that's attached to it. And that's the kind of significant difference here, really, is that these two things are linked together, which actually technically means you can animate individual objects in Forest Pack as well. If you animate the marker, the tree that's attached to it moves as well. So this is a slight change in Forest Pack. And the other big change is the ability to use p-flow objects. So for the lanterns at the front there, we can, for example, distribute those using a p-flow object. So we've got a simple p-flow object, just scatter some particles upwards, nothing fancy. And we've got a new distribution mode here, particle flow mode, which lets me pick that from the scene, and then we place particles on there. You can match the scale and alignment of the particles, and there are various things like particle time, particle age, and stuff like that that are exposed in Forest Effects. So you can write Forest Effects to do interesting things that relate to particles, like you could control the animation of the objects, for example, based on particle age, and things like that. Ignore the fish. You can use animation nodes as well, I guess that's the point. You can use the animation nodes along with particles too, so that you can see how it goes. I'm going to skip that because that's the fish. Okay. So that's kind of Studio Niskota as an excuse to talk about a lot of Forest Pack things. Has anyone got any questions about that? Because I'm going to quickly try and whip through the Bertrand Benoit thing and talk a little bit more in depth about RailClone, if that's agreeable. So how many people have seen this scene by Bertrand? Quite a few, I know. So Bertrand sent me this scene. I was supposed to have made a tutorial from it ages ago, but I never did. And it's a really interesting use of RailClone, because so much of this scene is RailClone. Basically, it's just a shell. If we have a look at the scene setup. Here's how it looks. Sans RailClone. So basically, we've got in here just some basic geometry to define the shape of this hallway. Come on, video. There we go. There's some basic geometry that defines the kind of shape of the building. There are some exterior buildings which actually are RailClone, but I haven't looked at them in this. And then this kind of central atrium. And then there are some splines, really. There's some splines to help define where these areas are going to go. So some splines for the walls on the side, some splines for the lift shaft at the end, and some splines that go around this roof, which we're going to deform, the glazing on the roof using RailClone. Segments. Preparing segments for RailClone will make your life an awful lot easier. It's just about getting the alignment of the pivots right, really. Not necessarily location, but the rotation of them. So this object, for example, is upright at the moment, but when you scatter something with RailClone, it goes along the spline, along the x-axis. So the easiest thing to do is just to turn this around and fold it down flat, so it sits on the x-axis like that, and just reset the x-form. And then that's oriented correctly for RailClone. You won't need to go in and fiddle around with the rotation settings or anything like that. It saves a lot of headache. And essentially, the pivots aligned there too. Essentially, all of the other objects are aligned this way. The other thing to note is that even the 2D array stuff, which we'll come to later, which are these kind of walls here up to the facade, so these are up like this, they're still laid down flat, because the 2D array is also built on the XY plane. So you want to lay down everything flat in the scene, even if you later rotate it upwards. Okay. So I think the roof glazing is fairly straightforward. What I'm going to do is skip to... The roof glazing is basically like the... if you're in the first session, the roof glazing is essentially the same as the power cables. It's just a couple of segments deformed along the spline. So rather than repeat that, I'm going to move ahead. The lifts are the same thing. It sounds like because they're incredibly detailed geometry, so it sounds like I'm skipping over something that's really complicated, but actually there are 3 massively complicated segments in this that he's just modelled almost all of that geometry, and there are 3 bits. So the bottom bit, whole floor, top bit, whole floor, middle bit, repeated a few times, whole floor. That's how those have been done. But what we haven't talked about yet is the A2S generators, the second and most sophisticated type of generator in RailClone. And just like the linear generator, this has a number of different inputs that you can target, a number of different parts of this 2D array that you can target, but it's got a lot more of them. So instead of having the 5, it's got like 13. So here are all your possible points in this generator that you can target. So you can see how sophisticated you can make these objects. It's essentially a stack of linear generators, but by being able to target the rows separately, you get a lot more flexibility. So we can go into the start, we can go to the end on the other side, we can go into the corners. This is the vertex corner. Then we've got the top and the bottom. Then you can go into the top, bottom, and left and right corners, like so. The corners of the actual array. Then you've got X evenly spaced intervals along the X-axis, evenly spaced intervals along the Y-axis, and then default fills in. So that's a lot of different places you can put geometry to create really interesting objects. As I mentioned, orienting this geometry is the same as orienting it for the L1S generator. Hopefully I'll recover. Yeah. So because the array is flat, your segment should also be flat. I can't stress this enough because it's a really common mistake people make. Just because the facade is upright, doesn't matter. You should lay it down flat and then reset the X ones. Then it will work better in RailClone, or it will at least cause you less headaches trying to rotate it using the transform settings afterwards and trying to get it. Just rotate it flat and reset the X one. So in this scene, there is a floor. It's kind of a marble floor, and it's randomized in really interesting ways. It's created with RailClone. So it has a closed spline to define the perimeter, and then some holes in the middle of it where there's the kind of sort of well in the middle and the well for the lift. So we can learn some interesting things about RailClone by looking at how this is built, because floors are a particularly common usage for RailClone. First of all, I'm not using an XY spline, I'm using a clipping spline, because the clipping spline has this extend XY sized area mode, which means it will automatically create an array that's big enough to fill that whole area. Then you can add a tile, piece of geometry, in this case it's just a simple plane to illustrate, and I'll pick the clipping spline from the scene and it fills it in. So it's just filled that area, you can see it's cut out. Already that's quite a handy time saver. I also want to be able to control this tile, some of the scaling and things like that, so I'm adding a transform operator there. I'm going to just pick the spline again because I was missing the edge, right? So it's a way of resetting the spline, that's quite handy. So what I want to do is I want to change the fixed size of this. So you can see from this transform operator I can change the scale of this segment, but actually I want to randomize it. So what I'll do is export the Y fixed size of that object. And I've wired it to a randomize operator. So you might wonder why, earlier when we randomized those planks, I just used the transform settings. In there you might wonder why I'm not doing that. And it's because using the random operator, number operator here, wired into the Y fixed size, gives me some different opportunities. Basically, it lets me choose when to create a new random number. In this case, I want to create it per row. Right, so each row has a random height. If I left it as per segment, each piece of geometry would be a different height, and you'd end up with holes in it. Each tile would be a different height, and they wouldn't fit together properly. So this particular style floor, each row is randomized. So we'll change it here, you see, to Y, array Y row. You can see now, see from back, you can see the row is a random height now. So controlling randomization using that is a really handy trick. You use it all the time for various things. Of course, we want to be able to control this from the modify panel, so you can export the minimum and maximum values from this random number, attach numeric nodes, and then you can control it from the modify panel. Which makes life just a bit easier if you're going to be used to start. There we go. So we can control it now from down here. Okay, so that's fine. We've got the randomized rows, but you also want to randomize the offset, because at the moment the kind of verticals are all still sort of in the same place, but you want to randomize them, each row horizontally as well. So, in order to do that, we need to start using some different parts of the array. So first of all, I'm going to wire the same transform into a new transform operator and wire that transform into the left-hand viewport of input, which is called start now actually in Forest Pack 6. Left in Forest Pack 5, start in Forest Pack, RailClone, sorry. You know what I mean. In the new RailClone, it's start. Okay, so now I've got that transform there, I can use the transform randomization tools to randomize the scale of that and create the interesting offsets, which is what I've just done there. So that's all pretty straightforward, but what if you want to add, I mean that would be okay if you want to task, what if you want to add grout between all those tiles? That becomes slightly more problematic. You want to add another segment just to add a little bit of grout between all those tiles. Bertrand had done this, so we will do it too. So now we need to get slightly more advanced with some of these operators. And basically what we need to do is to create a pattern. So we want another transform operator. I'm going to export the parameters. This time I'm going to use the fixed size Y and X. And I'm going to bring in a new segment, which will be the grout segment. So I'm just bringing in a brand new segment, which is the grout segment there. Again, simple at the moment, could be whatever geometry you want. I'm going to add a sequence operator. Sequence operators create a pattern, basically, alternate between whatever's attached to them. So, for example, what you're seeing here is a sequence operator on the x-axis, and you can see it's going between full-size tile, grout, full-size tile, grout, full-size tile, grout. Yeah, that's what it's doing at the moment. There's nothing much to it except that you can change the counts of these two. So if I wanted 2 tiles and then grout, you can change those numbers from up there really easily. But at this point, all we need to do is we scale this grout so that it's not that size, basically. It's the wrong size at the moment. We want it to match the width the grout should be. So I've already exported the values for this. So I've turned on fixed size, which are these two exported values, X and Y. I'm going to take the Y fixed size value there, and I'm going to wire it to the Y fixed size value there. So now the grout and the tiles are the same height, but they're also too wide now. So now we want to control the size of that grout. So there's a new numeric node. This is going to be the grout parameter, the grout size parameter. I'll add that to the X size input, so I'm controlling the X size of that grout. And now, you can see now here that this is the grout. So all I've done really is control the size of it this way, using the randomize operator, so it matches the rows, and then I've added a new parameter, which is the grout size, and I'm scaling it on the x-axis using that. That's all I've done. And then I've sequenced it, so it's one after the other. So we need to create the, we need to also create the grout on the y-axis now too. So you would take a new sequence operator, wire it to the existing sequence operator, so you're wiring one into the other, and this time you need to come in and change increment onto y. There's a little drop down there that just changes the axis that sequence increments on. Then I can wire my grout, a new grout in to there. So that's working, kind of. you can see I've got the grout rows there, but what's going on? Well, it's because of the start input. So I've only wired this to the default input now, so in my default input, you can see I've got alternating, I've got my alternating tile, grout, tile, grout, tile, grout. But in my start input, I've only got tile, and then tile, and then tile, and then tile. Right? Because there's a tile on my grout rows, and that's what's causing this to push up. And that's an important principle in RailClone to understand, is that each row is determined by the height of its tallest segment. That's a sort of fundamental rule of RailClone. So because this segment is very tall, it's pushed the rows above it up. Yeah? They're not like Tetris, they don't drop down and interlock. Each row is calculated independently and stacked above according to the highest segment. So the easy solution is to add that sequence effect to my start input as well, so that I've got grout in my start input that matches. So you add your sequence, add it to the start input, add your tile to the start input, and then add your grout to the start input too, making sure it increments on the y-axis. There we go. So you've got a floor style, which is randomized on the y-axis for size, the offset is randomized on the x-axis, and I've got ability to control the tile height, minimum and maximum, and the grout size, all from the parameters panel. So that's a pretty handy little style. I'm going to skip this. Bear with me. Okay, texture. So, obviously this is no good if you have to go in and then remap every one of those tiles because you've scaled it in some way that's fairly unnatural. So what RailClone allows you to do is to automatically box map any geometry that's applied to it. I can apply UVWs automatically to this according to real world size or just by specifying the size of the box. So you can see what I'm doing here. I've got apply box mapping turned on for the tile geometry. I'm giving a length and a width and a height. And when I was recording this, for some reason the viewport didn't update, but it will in just a second if you give it a second. There it goes. So this is applying this after you've scaled it, after you've done everything else. It applies a UV box map over the top of it so that you can get your geometry on there. But what about if you want to randomize it a bit as well? You know, there are only actually a couple of maps in this scene. You want to create kind of a randomized marble effect. For that you can use a UVWX form node. And what this lets you do is randomize the tiling. So I go between 8 and 15, for example. Randomize the tiling per tile on that. You can randomize the rotation as well. Like that, so I get some really interesting randomization. And then of course on top of that, to actually randomize the bitmaps, you've got RailClone color, which is the same as Forest color, but for RailClone. So that has some interesting potential, and then you get this quite nice randomized floor, which Bertrand created for this thing. I'm aware that I'm running out of time. I'm going to skip this too. Okay, so the facade, I'll probably finish on this, but let's look a little bit at creating the facade itself. So the facade is another 2D array. It has a spline. So we just pick one of these edge splines from the scene. We then need to add segments, of course. And in this case, I'm not using a second spline. I'm not using a spline for the y-axis, because instead you can just specify a size for the generator. In fact, you don't need to use any splines if you don't want to. You can specify sizes for both axes. But in this case, I'm specifying a size. So we've attached our base geometry there, and you'll notice it's displayed flat, like I said. What we want to do instead is rotate it, so you can do that too by going in and doing that. And the general rollout for the array, which I'll do in a second, I can just fiddling around. There we go. X rotation, 90 degrees, we'll just flip that round. Okay. So now this is building in the right direction. We had to lay our segments flat first.
Wait, can you explain that again? How come you rotated it and then rotated it?
Yeah, because if I hadn't rotated these segments first, like this, because the array builds on, basically the array builds flat, X, Y flat, so it'll build, you know, in front of me like it's on the floor. If I left the segments upright, then they would be in the array upright. Yeah, the width glass would be towards me and it would stack up glass front towards back of them, so I have to rotate it down. I know it seems weird, but it's just right thing there. I think when you predominantly use RailClone for things that are vertical, it seems odd to do it. But then when you start doing things like floors, like you did a moment ago, that seems more logical that you put the tile flat. Yeah, it's just that step where you rotate it that causes the
It
confusion.
makes sense with the map you made of like the default start.
Yeah, yeah. Okay. So the other floors, let's stick those in there. Should be fairly straightforward. It's actually a fairly straightforward start. So we've got a few other floors here. We want to add our default floor, which will just fill up whatever's left. I'm keeping it quite low at the moment because I'm just displaying full geometry in the viewport, just usually a sensible idea or something like this. Because of these little lights here, there's a gap. So I need to just change the padding, which remember we looked at the beginning, just to pull that back down. So just pull that back together. Do the same thing for the default segment as well. So then we're going to take get the top segment as well. So we've got one top segment here, and we'll just wire that into the top input. Top input. And then we've got a top segment. Again, it's full geometry, so it's a little slow to react. So then you've got basically you've built your facade. It's adjustable now. But of course there are a few variations which we need to look at. There's a door on the bottom floor. There's a door around the lift shaft on the other floors too. There's no variations on top. So let's look at how you add those and control them. So what I'm using is a selector operator to pick these. You could use conditional, but you'd end up needing a bunch of them. And what the selector operator has is a spline material ID option. So what it'll do is it'll pick whatever's connected to it based on the material ID that you assign to the spline. That's a really quick way of making a conditional style like this. So now based on that, I can wire these in. So I'm wiring some of them in multiple times because I want them to appear, for example, this one I want to appear on spline material ID 1, 2, and 3, and then this one I want to be on spline material ID 4. So I've wired it to the fourth input, just duplicating it. There's no kind of memory hit for doing that. It's just an easy way of doing things. This one I've got 3 different objects potentially on the ground floor. So what I'll do here is wire these in the same order that I want them to appear on the material IDs. So I want the second one to be on material ID 2, I want the other one to be on material ID 3 and 4. And it's about making those two things match. So you know some of them will have will create a different object on the default floor and some will be on the bottom. I'm making sure bevel mode is set to none so I don't actually slice anything as I add vertices to control the spline material IDs. Because otherwise you know what will happen if I add a vertex to control the spline ID, I'm going to cut the geometry up. And I don't want that. You know, we saw that on the boardwalk at the beginning. So you get rid of that problem. And now what you can do quite simply is go into your spline and you can just change the material IDs in the spline. You can configure your whole facade. And the nice thing is it's parametric, so you can go back if you change your mind and you want to move things around a little bit, you can easily change what geometry is displayed just by changing the base spline and changing the material IDs on the spline. You can see the geometry, maybe you can't see from the back, but the geometry is updating based on changing these spline IDs. See here we have some doorways where the lift shaft is. We've got a doorway here, we've got a panel here which has no glazing on it at all. I'm going to skip the conditional operator. Okay, so this will be probably the last thing, but there's also in this scene, at the moment you've got geometry on the walls, but it's the same geometry. And what we want to do is to add a little bit of natural variation to that, just to bring this scene to life a little bit, like it's inhabited. And what Bertrand did was randomize the opening of the windows, and he added blinds to the windows too. He did it in a fairly straightforward way, thankfully, which was that rather than do it window by window, he had these sort of patches which fit into this geometry. So he's got 3 types of window here, which are open in 3 different angles, and he's got a few different blind configurations that just fit in the windows at different points. The pivots are aligned, so if you align them with the geometry, they fit in the right place. So all you need to do is you need to randomize These are the windows, for example. You need to randomize the windows, and then we attach them to a compose operator. The compose operator has a couple of different modes. So the most common one is sequential, one thing after another. But it's got a second mode, which is much more useful in this case, which basically is grouped. And what group mode does, it aligns the pivots of the objects that are grouped attached to it, so they appear in the same place. So if I attach my base geometry to it first, for example, then anything else I attach afterwards will be aligned to that one's pivots. So there, I've just filled in the windows. It wasn't very obvious in the render, but I can do the same thing with these blinds. So here I've got a bunch of blinds. Here are my blinds, attached to a randomize operator already. If I just take these and just wind them in to this existing compose operator, hopefully you should see them come up in windows. There. So they're now randomized in all these windows. And they're randomized per segment, so you've got quite a lot of randomization there. By the time you've got that, plus the windows opening and closing, you've got some, it's not detracting, but you've got some subtle kind of variation. And this was the kind of trick he used to add that little bit of extra humanity to this thing. It's a really nice little trick, I think. Skipping a compose operator. Okay, so the last thing, at the moment this is square, the building's this shape. But obviously we need to clip it. So very straightforward. There's a spline in the scene that's a closed spline, you can see at the front here. If I take a spline object, actually, come on, I'm pointing to the spline there. Taking the spline, I'll pick it from the scene, and then wire it to the clipping input. It's disappeared because it's clipping it on the Z-axis, it's looking down for it. So what I need to do is just change this projection mode to Y. And then it's projecting it that way, it's cutting that building. I need to change for no slice to slice because I've turned slice off like I just said at the beginning. Turn slice off, you don't need it. In this case I do need it for the clipping object, so I've turned it back on again here. It's overriding. And then that's that facade done. The other side is just the same as that, but mirrored. And that fills it in. The elevator at the end was just a linear array with one spline going up through the middle and 3 segments, bottom, top, and middle. And the roof was one segment, just deformed along the curve along the top. A much more simple scene than it looks in terms of the way RailClone is used to create it anyway. I wouldn't say that his modelling of these segments is simple because they're quite sophisticated. But the RailClone use isn't that bad. And that looks daunting, that graph, but it's not too bad when you sort of get into the nuts and bolts of it. I don't think. There's loads more I can talk about, but I'm aware that I'm seriously running out of time. So I will hand it over to any questions that you might have about anything. Or, otherwise, we can say goodbye.
Do you think you'll make a tutorial of that?
I already have, actually. Yeah, it'll be out within a few weeks, probably.
The whole project? Or little bits of it?
It's the whole project. Well, it's the RailClone part. What I haven't tackled is how Bertrand models his segment, because only Bertrand knows that.
Yeah.
But he sent me the RailClone stuff, and I turned that in. Thank you. I turned that into this.